Writing a program that can only do straight things in an order isn't that useful. There are three primary structures for programs. We have the iteration where you're doing things one at a time, like we've worked with up to this point. You have the decision structure where you can do an if-then or an either-or scenario, which we're going to work on today. And then you have looping, where you can do the same thing over and over again, and that's coming up soon. Today we're going to talk about if logic, and all of us understand this. I like to tell a story about my youngest son, Matthew, and use this to explain that everybody knows how if logic works. So when he was young, like 10 years old, if I had told him, if you clean your room, I will take you to rent a video game, everybody knows that if he cleaned his room, he would get to go. If he didn't, he wouldn't. And you can make it more elaborate, where if I tell him you have to clean your room and take out the garbage if you want me to take you to rent a video game. Or I could do, you have to clean your room or take out the garbage, and we can go get a video game. So he'd have to do one or the other. In an and scenario, he'd have to do both. In the other scenario, he could pick which one. So we're going to work with all of those flavors of programming logic today, which mirror logic in real life and should make a lot of sense. So in most programming languages, Python included, you handle that sort of decision statement using if logic. So we're going to be using the if command, though we will actually not capitalize it when we write it in programming. And the way this looks in flowcharting, we'll do a really simple decision that we're going to look at. Let's say that we're trying to decide if we're going to bring an umbrella. Low-tech people will look out the window and see if it's raining. Me, I ask Alexa, hey Alexa, what's the weather? If Alexa says it's raining, I will take an umbrella. If not, I won't. But either way, we have a no or a yes option, and it can be done either going straight down or across this way. Actually, we'll do this side is no, and this side is yes, because I left more room to draw. So if no, we'll just drop down to our process, go to work. If it's yes, we'll include bring umbrella. Then go to work and get on with my day. So that's what the visualization of the logic for an if statement looks like. Every programming language has their own syntax. That's the grammar rules of the language. Just like English has grammar rules, so does Python. If you're coming from another programming language, you often end a sentence with a semicolon or do some sort of way to indicate the end. In Python, everything's done with indentation. Let's look at what this would look at in Python. So with Python, we would be doing a print type statement. So we would have some variables, rain, and we're going to set rain equal to true. And we will then do a decision tree or decision statement after that. If rain equals true, and this is where I have to check because in some, you have to have a then statement, but not here. But we're going to have a colon to indicate what will be done, and we'll tab in, we'll print take umbrella. So since rain is true, we would print take umbrella on screen. But it doesn't always work exactly this way because this could have a different value. One of the most important things you need to know about the programming syntax of Python is that equals and equals equals have two different meanings. A single equal sign assigns a value. So we're setting the variable rain equal to the Boolean true. And we'll spend more time on Booleans, but they're simply true-false statements. It's a specific type of variable. This double equals is a comparison. And one of the most common errors at this point in programming is to use the equal sign instead of the double equal sign, because you're used to thinking if rain equals true, not if rain equals true. There are some other options and ways to modify that we're going to get into.